answers on past solar installation practices. So before we start, my name is Daudi John. Here from technical support, and here with me is engineer Kunle Olorunkayode. I'll be answering all our questions. To ask, you can just start compiling your questions on the chat box, and if you want to, come on live, you can unmute. But please let the environment be a serene environment. Before we start, I would like to take us briefly on who we are. We are Genes Technology, and in Genes Technology, we are into sales and distribution of solar products. Products such as the LED lighting, the solar street light, rechargeable fan, Genex inverters ranging from 3 kilowatt to 15 kilowatt respectively. And we have the storage lithium ion, including the AGM. So for the inverters, we have 3 kVA, 5 kVA, the 6 kVA, 8 kVA, 10 kVA, and the 15 kVA, which is three-phase inverter. For the storage, lithium-ion storage, we have it available in 5 kVA in 24 volts and 48 volts. We equally have this 8 kVA in 24 volts. We have the 10 kVA, 10 kilowatt hour. We have the 15 kilowatt hour and the 16 kilowatt hour. So aside sales of solar product, we equally do installations, and we take upcoming installers and entrepreneurs through the academic section. We have which we just currently concluded a batch in the month of June. Tentatively, the next batch will be coming up September. So we hope to see more students on board. So thank you very much. I would like, while we compile our questions, there are some questions that are frequently asked by installers that which will be taken intermittently as your question is coming in. So like I said earlier, we have, if you have your questions, you can compile in the chat box. Please endeavor to put the raise up hand. And if you have any question you want to speak, just unmute yourself, but ensure the environment is a serene environment. So I'm going to call on the facilitator, the person of Engineer K, to introduce himself at least. You need to hear him. So Engineer K, good morning, sir.
Good morning, everybody. My name is Olorunkayode, and let's go along the show together. Thank you.
All right, thank you, Engineer K. So while we continue this program, let's quickly take some of the few questions that are commonly asked by the installer. Like number one, we have, how important is earthing in a solar system? Engineer K, kindly help us to respond to this.
Thank you. Earthing is very important to let me just use this, to life and property, because it's not only the system installed that you want to protect the system and protect the people, anybody that may come in contact with it. Because if there's a fault on the system and is not earthed, and the body of the equipment happens to have contact with life, there is nothing to drag it to the ground where you stand as a human being. So when you touch the body of such equipment, the current on the body of the equipment wants to look for a short distance to the ground. And at that moment, if the human being is the short distance to the ground, the current will flow through the person. And then if the current is heavy, the person will have a broken veins or blood veins broken, or eruption in the brain, anything that has to do with the blood, either brain or heart. That's when they say the person is electrocuted and is dead. So if it is earthed, when you touch it, you may not even know. But the fault is somewhere. And if it's heavy, because of other breakers, if heavy current wants to flow through that section, because the equipment is earthed, a breaker will trip, which is a signal that there's a problem. When you put it on back, it will trip again. So if it's an installation that is equipped with earth leakage stuff, all those protective devices, it will trip. You know that there's a problem. Make sure you test, check, and resolve it before you continue to use such system. So it is very important to have everything connected to the system. Thank you.
All right, thank you very much, Engineer K. I think this also boiled down to a question that the installers is a bit confusing, and they needed clarity on this as well. Should I connect lightning arrestor and earthing of a building together? Is it possible for these two to be connected together, please?
No. It is not advisable to connect lightning arrestor and earthing of a building together. Because when you are doing your solar system installation, which we said is important to make sure that earthing is connected to the system, you don't need to connect that earthing to lightning arrestor, because the earthing of the building can be used on the inverter, because the general earthing of all the appliances in the building. It's only when the building earthing is poor, that's when we advise that you get it repaired or you do a separate earthing for the system. And once that is done, is achieved, you have a good earthing connected to the inverter, then the earthing which is coming from the lightning arrestor should go straight to the ground, because the advantage of that lightning arrestor is to capture the high voltage, very high voltage spike in the space, capture it and drag it to the ground to avoid a flash going into any cable, which can travel through the cable into the appliances. So the element up there will have attracted it and take it to ground. So you shouldn't connect the earth rod of such lightning arrestor to earthing, because when it happens, if one fails, if the earthing in the building fails for one reason and you have already terminated it, that means the flash from the roof is going to your appliance or your equipment, which is dangerous. It's going to knock them out. So it is advisable and professional to have them separated, but they are all going to the earth, but at separate points. Thank you. So now the cable that will be used for earthing is also playing a vital role in this case. You cannot use a tiny cable, for instance, maybe 1.5 mm from the roof to the ground for lightning arrestor. You have not arrested anything. In fact, you have opened more room, because by the time the rush comes from the roof, it will just be wasted along the cable, or the cable even get disconnected, hot because of the current, because of the lower gauge. And when that happens, it's useless. It's not working. Then the remaining flash maybe that the roofing sheet attracts, can go through anywhere and get itself into your solar system, still getting the damage. So the cable that is coming from the roof must be thick enough. That's why you see in some places they use 25 mm, they use 35 mm, depending on how big. If you look at those earth tape, they are thick. They can accommodate every current and drag it to the ground. Thank you.
All right, thank you very, very much, Engineer K. Yeah, should I connect the earthing of surge protector to a lightning arrestor or to earthing of a building? Is it proper to be connected in such drain?
Connection of earthing. Henry is coming. Connection of earthing to surge protector. It is normal to connect the building earthing, which you are using for the earthing of the whole system, to get it connected to the surge protector, or you do a separate earthing for the surge protector. Because we will look at it that, okay, why do I need a separate earthing? If it's easy to do, just one rod, you have connected the surge protectors to it, and it will be a reference that is sure, because surge protectors they will function well when that part of it is connected to earth. If it's not connected to earth, you only connect positive and negative, it may not work. It may not function well, because it's referencing, if there's any excessive flash or anything, it's not dragging it to anywhere. It's within the positive and negative. It's within the live and neutral, because we have a surge protector connected to the DC, which is solar input, and we have those that are connected to the live and neutral inputs of the inverter, which is a grid. So their earth connection should be connected to earth cable, and you can use the earth cable if the earthing is good, which is connected to the inverter, or you prepare a separate earthing for them. So that's the thing. You don't connect to lightning arrestor, because if lightning arrestor strikes, it's coming into it. Let lightning arrestor be an independent wiring on its own. It will stay separately, and once it catches the flash from the space, it drags it down separately. That's his own work. It shouldn't have anything to do with the inverter stand there, the inverter connections, all other terminals that are directly connected to the inverter. So that is it. Thank you.
All right, Engineer K, thank you very much. I have a question from Mr. Sholola Gbenro Timothy. And the question is the same thing with what I wanted to ask earlier, which is next on the line. Okay, what are the basic settings on inverter after installation? It's the same thing with what I have here. That now, is it okay to leave an inverter's default setting when commissioning a new system, sir? Is it okay?
It is not okay to leave default setting on your system when you are doing installation. The manufacturer has already put all these things there because they know that other components have their ratings, and you want to bring them together to work, to function as a system. You must consider them. For instance, you want to use 200 amp hour batteries, maybe 4 in a string. The manufacturer does not know whether that's the battery you want to use. What they have created is the range of current that you can adjust. If the 200 amp hour battery requires 20 amps to charge, and then manufacturer has set 60 amps because the inverter is big, can accommodate even 100 or 120 amps for charging. It is your own remit to go and check and make sure that you follow the specification of the battery, set the charging current accordingly. If not so, you are going to blow up the battery by overcharging, because you'll be feeding the battery with 60 amps when the battery recommended charging current is supposed to be 20 amps. So many other parameter settings like that you need to set. And then it depends on what you want or what the client wants. For instance, the client wants when the battery goes down to almost 20%, that's when the client wants grid to be acceptable. These inverters that are hybrid today, they have all these functions. So it is your own remit to go check which settings is going to do this for me, so that the clients can use more of the battery, more of the solar, until when the battery is going down to that 20%, that is when it's going to accept grid, so that it reduces the cost of energy from the public source, because that's what many people want to cut off. They don't want to, I can't have inverter, I have solar panels now, and then I'll allow grid I'll be paying much on grid when I can cut down my cost using that setting. So there are many other settings that you need to do in the inverter. Some people don't like beep when the inverter wants to, when grid comes, they don't like that noise that it will beep to alert you. So it's optional. You can go there. If the client doesn't want it, you tell the client the implication. If you don't want, then you won't know when grid come. You may know through other ways, but inverter will not tell you that, oh, grid has come or solar has come or anything. You can turn it off. If there is a fault, if you don't want the inverter to report fault by beeping, if you turn it off, when there is a fault, the system will just generally shut down. You won't be alerted that, oh, you won't even know what happened. You will now be running here and there. What happened? This and that. So it's optional. Many settings are there. Time. There is a clock in some of these inverters. If you don't set the clock, it will be there. So battery level, battery shutdown, if you don't set it properly, you can over discharge the battery and you get the battery damaged within a short time. And then they will now tag your installation as not maybe the battery is bad, it's a fake battery, or the inverter is not working well, and you install within 2 weeks, and then the battery is having problem and all that. So you need to put all these settings in proper position. So it's very important. So I think that answers that question.
All right, Engineer K.
Only two? I want oil. Sorry, ma'am.
Now, this is coming from Oladi Meji. Say common neutral in inverter. That's common neutral in inverter installation. Is asking now that is it the best, or does it have any effect on inverter installation?
It is the best because it serves as a protection for the whole system. Now, this is how it works. Unless if the manufacturer of the inverter wants that, do not connect neutral of the input to neutral of the output, because that's what makes it common. And then if you are wiring it to a building and the building has neutral, that means you must isolate it. If they have warned specially and they put one in there that you should not do that, you have to be careful. But if not, it is the best connection. So when you connect neutral input and neutral output together, if after you have done your installation, there's a problem on the grid, the pole, and they dropped the wire, and they came back to correct it, by so doing, they interchange the live and neutral, your inverter is not in danger. But if you have not done the common connection, your inverter is in trouble, because you have a voltage between the neutrals that's high. You can have as high as that 240 between the two neutral input and neutral output, when it's supposed to be the same thing. So that can pose danger to the system. Because once it's reversed, if it's common neutral, everything is reversed. Inverter does not know whether the grid is even reversed, because it will see live and neutral. It will see the 220 volts and use it to process to give output. The output is also, everything is reversed. So if they cannot tolerate it, that's why you have all those breakers that are properly rated around the inverter. If current flows through a wrong section and the current is excessive, the appropriate breaker will trip. That tells you something is wrong. And when that happens, you correct it. Maybe by then you now know, oh, it's because they have reversed the input. That's why this breaker tripped, because that's what's going to happen eventually. So it is a good practice to make sure that they are all connected together, because they reference the same neutral, so that you won't be seeing different voltages at different points. Use the same neutral to check input and output. When you are testing, you are referencing the same neutral, which makes your troubleshooting to be easier. Thank you.
All right, before I move to the next question, let me quickly take this from Annie Limitless Solar Tech. Please, kindly unmute and ask your question.
Okay, so thank you very much. I hope you can hear me. Good morning, everybody.
Annie Limitless, please unmute and ask your question.
Yeah, can you hear me? I have unmuted. Can you hear me?
Yes, I can hear you.
Okay.
I hope every other person can hear.
Thank you so much. So what I want to speak to is what you treated just before this issue of common neutral. So I just want to put some kind of balance. When you talk about settings and changing the settings, I completely agree with you that you should change settings to reflect the situation you find yourself. Like we gave an example using batteries. If you're having more batteries and you have to change to factor the charging current and all that. But just to add another side to it. So I know that sometimes you find yourself in a situation where you're using a new product. You probably don't have full information about that product. I'm not saying it's right. I'm just saying it happens. And then you're trying to decide which settings to touch and which settings not to touch. It's always good to do your research to have the information, but peradventure, you don't have that information. I think it's always a better practice. When you are not sure, my own way of dealing with things when I'm not sure is I try to keep the manufacturer settings the same. As in, I don't change what I am not sure of. Because I always feel that when you change what you are not sure of, you are further complicating the matter. So when I am not sure, I try to keep the settings that the manufacturer has left. I feel it's a safer bet for me than for me to change what I am not sure of. I just felt I should add that as my own input, and maybe you can also speak to it if you don't agree.
Okay, thank you for your contribution. It is, yes, it's true. In some cases, in fact, in most cases, when you're not sure, you may want to leave what the manufacturer put there. But this is the side of it. What the manufacturer put there is perfect for the product, but may not be perfect for other components that are working together with that product. But the best thing is, before you change anything, copy it out. If you need to do video, if you need to write it down, take your time. Copy what is there originally. It is the best, so that when you miss your way, you can always trace your way back to what is originally there. Because when you set anything and then it results to another thing.
We can resolve it. How about it? Resolve it.
Hello. Somebody is not muted and is contributing.
So now the money has to resolve.
Hello, somebody is interrupting. Okay, so it's better to copy the original settings out, keep it. So when you make any adjustment, you can always trace your way back. If you make any adjustment and then it results to the inverter is now going on, off, on, off. Initially, it wasn't doing that. You are trying to set charging. And then now you have changed something and it's now doing that, which is even worse than what it was doing before. Then you can say, okay, let me return it back to the default. you know. So, and then it is advisable that anytime you want to do the setting, you should do one thing at a time. If you want to do a lot of settings, you should be sure. Please find out. If you are not sure, Google it. Google is there for everybody. You can check, well, how does this one accept? How does this one affect the performance of my system? If I use this, if I use this, you will be advised. You have more knowledge. And from that moment, when you see it in another inverter, because they may not coin it out the same way in different brands of inverter. I mean, in one inverter, it may be termed low battery cutoff. In another place, they may term it battery disconnect point or something. So you need to understand every detail about the equipment before you start changing. That's the best. So that's my own advice concerning that.
All right. Thank you very
Okay,
much.
thank
I
you.
hope that is clear enough, sir. So this is coming from Olu Folarin, Olu Oluwakunbi. Sorry if I'm not getting it right. So he's asking, he said, please, sir, is there any surge protector that does not need earthing?
If it doesn't need earthing, then it will not be provided with earthing. That's just a simple answer. If you see a terminal there tagged with the symbol of earthing, that is the earthing. But if it is not, if there, you don't have any terminal on the body, on that device, that surge protector, that means you don't need to connect earthing to it. Maybe they have, maybe it's a special device and that you operate and functions well without the earthing. So if it is there, you have to connect it to make it function better.
All right. I hope that answers your question, Olu Folarin. So this is coming from Taufik Kudus. He said, is it okay to link a solar panel with thunder arrestor? Okay, yeah, this is coming from Taufik Kudus. He said, is it okay to link solar panel with thunder arrestor, sir?
Okay, solar panel linking to thunder arrestor. They are both up there. And solar panel frame is iron. So definitely when there is a strike, both the solar panel frame and the lightning arrestor will receive it up there. But there is no connection between the cable of the solar panel, the cable that takes voltage into the inverter. There's no physical connection between that cable and the frame of the solar panel. So if you connect like lightning arrestor up there with the frame of the solar panel, it's okay. But the lightning arrestor cable now will go straight to the ground. It does not go into the building. It does not go inside the building for any reason. It doesn't go to the inverter stand. It doesn't go to any connection. It goes straight to the ground. So whatever it captures, whether it those that it receives from the frame of solar panel when it happens, and the one it captures directly, everything channels to ground. So that's it. So you can connect the frame to the lightning arrestor up there, or better still, more professionally, you connect the frames straight to ground separately. That's more professional.
Yeah.
All right. Thank you very much, sir. Let's quickly take this one from Macpella Anyawu. He say, if a battery can be overcharged, what is the importance of charge controller and the BMS of battery? Please explain, sir. Let me quickly take this again, Jinake. This is coming from Mark Pella. And we said, if a battery can be overcharged, what is the importance of charge controller and the BMS of the battery?
Okay, thank you. I will just use this analogy. There is something called overspeeding in driving, meaning that you press your accelerator and you want the highest speed, then that is overspeeding. The manufacturer of the vehicle, they already equipped it that you can control it yourself. You can say, okay, I want to speed at this point, I want to do this at this point. So the same way the battery charger has been equipped with adjustment to say, okay, I want to use this manufacturer said their own battery full point, which is bulk voltage, is 24. For instance, another manufacturer will say his own bulk voltage is 25. Another one may say bulk voltage of my own type of battery is 27 point something. So you need to choose, you need to go through their own recommended specification and then go inside the battery charger, whether solar charge control PPT or whatsoever, adjust it to that, such that when it's charging, that bulk voltage will not be exceeded. It is the function of the charger now to say, okay, because you have programmed me to stop the charging not to exceed 27. When I'm charging, I will not, when I get to 27, I will hold it on there until when the battery current decays. So, and then when everything is sorted, it will now go, depending on the function of the charge controller, to go back to float. So it is you that will set both charging current, because the charge controller does not even know how many batteries you want to connect. It's you that will say, okay, I'm connecting 2 strings, and these 2 strings need 40 amps. Okay, this charge controller can deliver 100 amps. Let me set it to 20 or 40 amps that is required by the 2 strings. Then for the voltage, the manufacturer said the bulk voltage is so value. Okay, you charge controller, I will program you to this value so that when the batteries are fully charged, this is the value they get to, and they will not be overcharged. I think that answers that question.
All right, thank you, sir. Let's quickly take this one from Mark Pelle. He said, please, sir, explain the importance of inbuilt GFCI of an inverter.
That's a ground fault circuit interrupter, or what is it? So it detects that there is a ground fault. For instance, you did not connect ground, because it's one of the latest improvements on all these systems. They are equipped with that function to monitor the connection of earth. If you activate it and you did not put earth in place, or you activated it, the earthing connection is poor, the inverter will be monitoring because you have activated and to shut down the inverter. It may be showing you a icon or showing you an indicator that the earthing has problem. So that's what it does. And if it's equipped with a function to shut down the inverter will not work. It will shut it down once that fault comes and is able to detect it. So that is the function. Thank you.
All right, thank you, sir. Let's take this from Oladimeji. He said, on the conversation of the setting the inverter parameters, when the inverter and the battery are communicating well through BMS, do we still need to set the battery parameters such as bulk floating, like bulk floating, cutoff, and charging current?
You will not be allowed if communication is properly established. If you are sure it is communicating, then the inverter will not allow you to set it, because the communication of where it's going to charge to, where it's going to rest, or the amount of current that is going to demand is inside the brain of the battery, and is sending it through the communication cable to the inverter that this is the way you should treat me. This is what I want. So whatever external settings you are doing around that inverter to make sure to override this function, if proper communication is established between the BMS of the battery and the inverter, will not work. It will override. If you set it, by the time you go back there, you see that the charging current has changed. It is now the battery that is giving command that, oh, inverter, please give me 100 amps. That's what I need now with the way I am. Of course, all this has been programmed. So the battery will not demand for the current rating that is higher than its own rating. If it is 200 amps, it can demand for that 200 amps for charging. So that is why it is important when you are choosing your cable size and everything, you should know that this battery, because it's communicating, can demand for anything. So you should be ready. You provide the system with the standard gauge of cable that can withstand the current and the breaker. So that's why it's important to rate all your component protective devices around the system properly, because if not, it will become a nuisance. For instance, the battery, you put a low rating of battery breaker, and then the battery demand for a 200 amps, and you are putting a 100 amps breaker. If the breaker will trip, or input breaker is not enough, because it's going to, when grid comes, it's the same breaker that will power the inverter for charging and then power the load. Now, inverter is demanding for every current, and you are using maybe 20 amps at the input when it's supposed to be like 100 amps. The breaker will trip. So all these are very important. So I think that answered your question.
All right, thank you very much, sir. Let me quickly take this one from Sir Debo. So he's asking, I think, a more technical question here. He said a charge controller is indicating panel, but the battery is not charging. It shows the following. That's a battery, 00 amp, 0.0 amp, another bat 28.6 volt. Then the load is 0.5 amps. The PV reads 92 on the screen. So, sir, what could possibly be the issue on this, sir?
Well, you are seeing no current and it's showing load. I think you are referring to a charge controller, external charge controller, right? So if it is external charge controller, they have the way they are designed, and they have a section where you can connect. Some of them have section where you can connect load to, and that load may be USB compatible and may just be a bulb that is controlled in the evening. Oh, solar is going off, then the bulb should come up, taking power from the battery, because the charge controller is connected to the battery. So that may be around that. But if you say it is charging properly and is showing these readings may be talking about the external load that is supposed to be connected to that port. Well, because you did not connect anything, you'll be seeing that is zero current and all. But the main charging current of the of the battery from the charge controller, if you establish that that is working well, you should be able to see it when you press some buttons of the charge controller. You scroll to where you will see it. If it's not displaying it on the default screen display, so you can press button to set for it. You see the battery voltage, you see the charging current, you see the voltage of the the solar panels. You see all those three things. So that's it. But if it's working properly and you are able to see all those ones when you press button, then your system is okay. But you can see check settings whether there is a way to set it such that it will, when you just press without pressing anything, you will see the display of what you need to see. Some chat controllers are like that. Some you need to press button and scroll there to see it. So that's it. Thank you.
All right, thank you, sir. Olufolarin is asking, what is the proper order of connecting surge protector, breakers, and AVR?
Sorry.
Okay, let me take it again, sir. I say, what is the proper order of connecting surge protector, breakers, and AVR?
Okay. The proper order of connection of surge protector, breaker, and AVR. AVR is automatic voltage regulator, which is a stabilizer when it comes to AC circuit. And surge protectors, we know what they are. They suppress ice spikes and all that. They are terminated across supply. Now, circuit breaker does not know voltage level. Circuit breaker does not know voltage level you are applying to it, but it is rated. The manufacturer will tell you that this circuit breaker can withstand so voltage, meaning that if you exceed the voltage, there could be arcing. You can jump the breaker when it's off, because it is rated 20 volts and you're applying 100 volts. When it's off, 100 volts can jump over and send wrong signal to another place. So now the order of connection of these three components that you mentioned is the breaker, the AVR, which is regulator, unless if you are talking of AVS, which is automatic voltage switcher, which is part of the components. But this is it. Let me even include that: AVR, AVS, circuit breaker, and surge protector. Now, your AVS, which is automatic voltage switcher, is monitoring voltage up and down and overload in terms of current. Therefore, it should be connected to the output of stabilizer, which is AVR. Your stabilizer comes in first, connected to the grid. Output of the stabilizer can misbehave. If the stabilizer is faulty, you can get high voltage, even higher than what you think you can get from NEPA. A faulty stabilizer can supply 300 volts. So your AVS now, which has been programmed not to accept more than maybe 240 volts, will be there to shut it down and show overvoltage. Then your surge protector can now be connected at the input of your appliance, the device, which is the inverter. Surge protector, that's where it's connected. The live and neutral of that device is like a guard. It's connected across the live and neutral, so that if the ice pipe comes and was able to ride through all other components, when it gets there, that one will chap it, because it's capable of sensing very high speed, high voltage. Before the inverter can even recognize it, that's a surge protector will have seen it, and then it will track it down and avoid allowing it to go into the inverter. So that is the way they are connected. For the circuit breaker, now your circuit breaker can be at the input first before the stabilizer, or you put the circuit breaker at the output of the stabilizer, so that when stabilizer has done its own regulation, it goes into the breaker. When you on the breaker, then it goes out to the surge, to the AVS, which is automatic voltage switcher. Then outside the automatic voltage switcher, you now have your surge protector. That is the sequence of a standard
All right, sir. Thank you so much, sir. Thank you, sir. Thank you, sir. Okay, this is from Taufik again. Taufik Kudus. He said, what are the most important settings that must be done before commissioning an installation?
Here are the most important settings to be done. Charging current of the batteries. Bulk charging voltage. If it's not communicating, if it's not lithium ion, you will set this. Charging current, charging voltage, bulk, charging voltage floats, low battery cutoff points. If you don't set this, you over discharge the battery, and then it will kill the battery. So those are very, very important, and those are the first thing you need to look at. Then before you now go to the function, how do I want solar input to interact? Is it that I want solar to just go to battery first, or solar should go to load first, and all that? So, okay, how do I want it? Do I want grid? Anytime grid comes, it should be the one to just power the load and cut off the solar, or when grid comes, grid should just power the load and allow solar to charge my battery. So all that are there. But the first set was those that I mentioned, the battery and the over discharge point. So that's it. Thank you.
All right, thank you very much, Engineer K. Please kindly confirm if you can hear us, because I can see some messages like no audio, I can't hear. Let's see if it's a general problem or it's actually a problem from our own end. Just raise up your hand if you can hear us, please. Thank you. All right, thank you very much. Okay, now we have this question. Yes, sir. You said the monitoring platform shows zero. That's if the monitoring platform shows zero. That's zero solar, shows zero solar production, but the inverter display show normal operation. What should be checked? Or do I need to take it again?
I heard you. Okay, if the monitoring platform shows zero solar production and the inverter display shows normal operation, well, you need to confirm. I need to understand what monitoring display is showing that. Is it remote monitoring on your phone? Okay, if it's the remote monitoring on your phone showing zero, and the inverter is seeing that solar is coming in and is utilized, maybe you can clamp it and see inverter display is telling you that everything is okay. And inverter can monitor the voltage and tell you the current that is coming from the solar. Then you may need to check the configuration of that remote monitoring. Maybe you need to reprogram it. Maybe you disable it and allow it to come up again, or check, restart it, or you separate it. You know, when you connect to Wi-Fi and the inverter, when you bring them together, maybe it's not proper, or it's not even the proper application that was used or something. So you need to check all that, because if everything is normal, whatever it sees is what is going to show. So it doesn't, is controlled by by default. So you may need to deactivate it and reactivate it and see whether it will be normalized. Or if your app is outdated, check whether there is a new update, then update. So that's what I can advise on this.
Okay, thank you very much, sir. Okay, I see this feedback that we are audible enough now. All right, let me check this one. It said, can I oversize solar array beyond the inverter's MPPT capacity?
Yes, for some inverters. For Genex inverter, we are sure. But for some other brands that I don't know, you may need to confirm from them so that you don't get the inverter damaged. This was designed in the inverter to make sure that you are able to extract maximum energy from the solar panels. It should not damage the inverter. But for other brands, because somebody called sometimes and told me his experience that when he did that, when the solar array was increased beyond the capacity. Beyond the capacity, not in terms of voltage now, because you should not exceed the rated voltage. If you do that, the charge controller is going to get damaged. Whether Fronius, whether any product is going to get damaged. If it's well protected, then it can now tell you maybe over voltage or something. But you must have been warned in the manual, which I'm sure of, that you should not exceed so voltage. But in terms of the capacity, that maybe they say is a 3,000 watt, that's the capacity that you can operate with. For our own, you can go beyond that. You can operate at maybe 4,000 watts. The combination of the solar panels can be about 4,000 watts. The charge controller will pick its own because it's a regulator. The charge controller cannot deliver more than 3,000 watts if that's the rating. So, which means early in the morning, you have more panels to deliver more energy. You may get your 3,000 watts early in the morning. That's the advantage. And then in the afternoon, if it's more and it's capable of delivering 4,000 watts now, you are sure that the maximum you can get is 3,000 watts. That is it. So this was done to avoid you saying, I just want to put 3,000 watts, which will limit the system to a point where if the early in the morning, because it's very low or the weather is bad, you can't get more energy. So that's the advantage of having more panels and then increasing the capacity of your solar panels slightly beyond the rated capacity of the charge controller. Of course, the manufacturer will also state in the manual that don't go beyond this. If you see the examples that they did in some of our manual, you see that they've exceeded some. Some they will tell you don't do this. So that is it. I only know of our products. I cannot guarantee you of other brands. Thank you.
All right, thank you very much, sir. We have this one coming up next, and is commonly asked. It's a direct question, though. You say, can I connect a new battery to an old battery bank? Is it ideal?
No. The reason why I said no is based on the basic knowledge of battery voltage and all that. Once a battery is old, it does not demand for heavy current. That's normal battery out there, like all those AGM. The charging current can reduce. The load current too. When you load it, you just see that it's going down quick. The time will be reduced and all that. So, but today we have technology performing its wonders by the introduction of lithium-ion batteries. There are still other batteries that are superb, that they may be expensive than lithium-ion batteries, but then lithium-ion batteries has come to stay. It can tolerate that to a certain extent, but there are conditions around it. If you have a battery, normal AGM battery that you have been using, and you want to connect another one in parallel with it, yes, it's not that they cannot charge together, but you need to observe the discharge current and charge current. the charge and discharge current must not exceed the new one, because whatever you are doing now is the new one that is going to want to bear the whole thing. The other one will just be following because they are connected in parallel. So if the new one is now taking 20 amps and the set value before was 20 amps because we are using one this when you want to now set the charging current, because you are paralleling another battery that is supposed to take 20 amps in with the old one that was taking 20 amps, but because it's old, when you bring the two together, you cannot adjust your charging current to 40 amps because they are two in parallel. Then you want to double the current. No. If you do, it is the new one that will be charged with that 40 amps and it will get damaged. That is overcharging that in terms of current. It's going to get damaged. So what you can do technically, which is not advisable for a customer too. If you're a technical person, you want to do this, you can do it. For customers, we just say don't connect old batteries with new batteries because it's complex. You cannot, it will take you a longer time and customers will not understand. So, but if you're a technical person, you want to do, you can do and follow. You know that, I can't increase the charge current beyond maybe 25 amps so that the 5 will be the one for the old batteries, while the 20 amps will be for the new battery, because the old battery definitely will be taking some current, but you should not take it high because the new battery will take the highest current. So that's that. If it's in series, it's even not advisable. Not advisable in series at all, because one battery will be there not working. Is either the old battery will quickly charge up and get disconnected, or get over voltage because you are connecting in series, and the new one wants to take higher current, it will push more voltage across the old one, and then it will get overcharged. Meanwhile, it's in series with the other one. So it is not advisable. It's unprofessional to do that. But for lithium ion, well, still within a certain age, you may be using a lithium ion battery, because maybe one is communicating, the other one, the first one maybe is communicating and is 100 amps, for instance. If you are connecting another battery to it in parallel, that is also 100 amps max, your inverter may not be able to deliver more than 50 amps. You can still connect the two together because one is 100 amps, is old. The other one is also 100 amps, is new. You cannot take more than this is that. Each of them will take whatever they can take, and they both follow up till they are filled up. So, but one will be connected. You can even connect the two if they are the same brand. You can connect them together to communicate. It doesn't matter. They will communicate and demand and regulate themselves. So it's better on lithium-ion batteries than AGM. Of course, you cannot connect the lithium-ion batteries in series if the manufacturer does not state so. So that is the answer to that. Thank you.
Okay, sir. Thank you very much. Thank you for that enlightenment, most especially on the lithium-ion battery. Okay, still on lithium-ion battery, sir. I have a question here. It says, should lithium batteries be fully discharged?
Okay, you said, should lithium batteries be fully discharged? Is that?
Yes, sir. Yes, sir. Should lithium battery be fully discharged?
Fully discharged depends on the inverter you are using. If it's communicating, of course, you can't fully discharge it because it is the battery that will send the signal that, oh, I'm okay. Where you have used me up to, I'm okay, I'm satisfied. You don't come and kill me. It will stop. If the inverter does not stop, it will command the inverter. If it's communicating, to command the inverter to shut down. So, but if it's not communicating, there is a safe point in the program of the battery that it will say it will shut down and get disconnected. That way, because it's not communicating, you now find it difficult to wake it up. So if a battery is not communicating and then you are discharging it, you are advised not to go below about 48 volts. It may look like you still have a lot of energy, because if you go below that, it may shut down and not wake up. If your inverter does not have a auto wake up function to start when the grid comes or when solar comes on, so that means you'll now be in trouble of looking for external power supply to boost charge the battery. So that's just the answer to that. Thank you.
All right, thank you very much, sir. Okay, I have this one. What is the implication of not configuring communication between lithium battery and inverter?
The implication is that you may not be able to get more energy used on your loads, because the battery has been designed that, okay, once it gets to maybe about 90% or 85% or 95% or there, depending on the manufacturer, it should shut down. But because it's not configured with communication now, you don't want to go to that point, because when it stops, it won't wake up. There's nothing to wake it up, because it's not communicating. So there's no communication to say, okay, there is power, okay, wake up, start charging and all that. So you want to play safe and you want to leave your low battery disconnect point high. That means when you are using the battery from 100% full, you will get to that maybe 48 volt, which is maybe about 60% or thereabout, 60% or 60 to 70 or thereabout, then it will stop. So that means that's the capacity from that point to the maximum is what you are able to use. That is just it. For every other thing, it will charge normally, it will discharge normally, it will do every other thing. But that is just the thing. And if you say you want to allow it to go down, I already told you the implication. So it now left for you, which one do you want? Thank you.
Thank you, sir. All right. Okay, this is coming from Taufik Kudus. Say, for example, if a battery charging current is 30 amps and I have two of it in parallel, do I increase the charging current to 60 amps or I should leave it in 30 amps?
If the recommended charging current of a battery is 30 amps and you have two and they are the same age, same brand, same distance, then you connected them in parallel, then you should subject the two together to double the current that's given, which is 60 amps if your inverter is capable. If your inverter is not capable, whatever is capable of giving, but it should be more than the current of one. That is it. It's safe to do that. Thank you.
All right, sir. This is still on battery. Now, a battery is not charging beyond 80%. Is that supposed to be a fault? Should it tell me to be faulty?
Okay, if a battery is not charging beyond 80%, there could be a lot of things, a lot of reasons. It's either is a manufacturer problem or your charger problem, because if it's not communicating and then you did not configure the bulk charging voltage properly, maybe it's too low, then wherever the inverter sees as the restriction to stop charging, that's where it will push it to. And if that point is equivalent to 80%, then your battery will not charge beyond 80%. So there's no fault anywhere, it's wrong configuration. Unless if it's communicating and then there is always power to charge the battery over a certain period, and then you all the time you see that it doesn't go beyond that, and then it's not taking current. Because one thing is for the battery to still be charging and it's not getting to before it gets to this 80%, or is at 80% while it's still taking current. If it's at 80% and it's still taking current and it's not going beyond 80%, then there is a problem. There's a problem with the battery. Because if any battery that is taking current is bound to increase in terminal voltage, and then the percentage will equally increase. So that's that.
All right, sir. Thank you, sir. Okay, let's go to the next one quickly. You say, Okay, an inverter display a grid over voltage. There's a grid over voltage fault. What should I do?
If an inverter is showing grid over voltage, that is coming from your generator or national grid. Now, it means that the voltage is high. Confirm with your meter. Is the voltage actually high? And if it is high, get a voltage regulator, which is stabilizer, for the input. That is number one. Number two, get a voltage monitor, a power monitor to monitor it, such that you don't allow that over voltage to always come into the inverter, because the inverter will not accept it. That means if it's too high. Unless if the voltage is normal and the inverter is showing that, then it could be a problem with the inverter. So that's the answer to that. Thank you.
All right, thank you, sir. Okay, for this, if a customer says an inverter fan is noisy, is this normal?
Yes, it's normal for a client to tell you that inverter fan is noisy. Depends on the place where the inverter is mounted. Some people, a little sound, they are sensitive to it. So some don't care whether you like put it in their bedroom or whatever is working, even if it's rolling, making like sound like siren, they will sleep. So, but for a customer to complain, you can also check, is it true based on your experience? Is it that that particular inverter is making a lot of noise, different from others? So if it is, then something must be wrong. But if not, if it's just that's the way others behave, then the client can be advised to relocate it from where he feels disturbing. That's the thing. If because there are other inverters that may not have fan, but they're extremely high. There is in terms of cost. If you see an inverter that does not have cooling fan and then is delivering power, it's going to be very expensive and it's going to generate heat. There's no way inverter will not generate heat. So if it's the sound that is problem, it's either to relocate it to a place where the noise will not disturb or get another one that's a bit noiseless, or some that but they are not common, they are expensive. That's just the thing. Thank you.
All right, thank you very much, sir. All right, to our participants, please, before we call it a day, in the next 10 minutes, if you have any question to ask, kindly raise up your hand or you drop a question quickly in the chat box. So, Engineer K, I still have one more question to take here. He said, when an inverter already has an internal protection, why do I need protective device?
Okay, I guess we can hear me. The manufacturer must have stated that you need to put such external surge protector, because all these external protecting devices are cheaper than the cost of inverter. And then you want to look at your own time too. You are in business and you don't want to put some extra measures, extra protection in place. If the inverter is the one to receive the attack and unfortunately get damaged, then you'll be forced to go and remove it for repair. You now look at the cost, the time you are going to waste, the energy, and then the cost of the inverter itself if the inverter eventually get damaged. So it is better to put protective devices that will prevent the inverter from getting damaged. It's not that they don't have internal protections, yes, but so that you don't wait until when the internal protection goes bad. Of course, an inverter has overload protection, and then you can play smart by putting overload protection as an external device, so that the one inside the inverter does not even see anything. Inverter will just be working without even seeing the problem. It's only when the external one fails, then it can now come back and the inverter will now fill it. Then with time, you can replace the external one and see it. But if you allow the inverter to be the one doing all this, the inverter can fail within a short space of time. And then it becomes more expensive to replace or to get restored. Thank you.
All right, thank you very, very much, Engineer K. We really appreciate your wisdom in impacting us and the enlightenment all through the session. Please, okay, let me quickly take this before I cap it up. Engineer K, please, an inverter cooling fan stop working even when heavy load is powered on it. Please, what is the cause and solution, sir? This is from Atom Energy.
If inverter fan stops working while it's still powering a heavy load, then you need to first of all confirm, is it that the fan is timed or is temperature sensitive, that it has not reached the temperature to start again? If that's not the case, then the inverter is likely to shut down on over temperature because it's going to complain and shut down because it will be producing heat and then nothing to extract the heat is going to shut down. So but if it's a fault and the fan, of course, if it's a fault on the fan or from internal components that is related to the fan, it will show an error code to tell you that the fan has stopped. For some inverter now, it's 01 and it will be beeping, giving alarm and all that. If that is the experience, then the best thing is to remove the inverter for repair, so that the fan it could come from the fan directly or from an internal component. So it will be diagnosed and then get restored. Thank you.
All right, thank you, Engineer K. In fact, you have indeed done justice to all our questions. And to our participants, I really appreciate you. Thank you for joining in. Please kindly note that the recorded session of this webinar will be uploaded on our YouTube channel. You can see it displayed on the page. Genex Technologies, the numbers are there. Thank you very, very much. We are looking forward to have you in our next webinar section coming up next month. Thank you so much.